Hello, I am Hiram Benroth, and I'm here to present my parser and lexer for my own HDL that I have designed. So to get started, this video is just going to be an overview of the code and my experience learning how to create a parser and a lexer. So first, I just want to start by showing you that it works. So here is an ALU. Um, it has a few um, properties that just um, it just has inputs, kind of like a add sub mul div, and then this. And pretty much what I'm just going to demonstrate is it parsing this unit into a abstract syntax tree, and we move on from there. So perfect. So I'm just going to run it. It's going to run, and then it's going to spit out the abstract syntax tree. And we can kind of compare the two. So above we've got the ALU. So the unit is ALU, the ports are A, B, select, and LED. A is 8 bits, which we can see. B is 8 bits as well. Select is only 2 bits, and then LED is 8 bits out. And then we've got 4 signals internally that aren't inputs, aren't outputs, but they're going to help us connect to different things. And then we also have the multiplexer and parameters. So um, this is a bind statement. So it's saying, oh, I need a unit that's a mux 4 to 1. Its name is this one. That's 8 bits because I passed in that. The width is 8. Then the port map is right here. So that's pretty much a demonstration. Um, and then now we can talk about the code. So here's my lexer. We can start with that. So pretty much the function of the lexer is to take the string values and tokenize it. So we've got different tokens, and pretty much what I do is I go through each token and I just match it with what it is. It's pretty simple in theory, but it's complicated in implementation. I think at least. Just because it's kind of hard to do. We've got a case statement for all the different characters. We've got seeing if it's white space, if it's the end of input, like if it's the end of a line, or if it's the end of the file. Um, and then we have if it's a digit, if um, and then inside the digit, we have to check to see if it's a binary digit, if it's a hexadecimal digit, different things like that, because they're very useful. So I use X, um, and then if it's not either of those, then it's going to be a decimal number, and then string does that, and then keywords, it has to, see if it's a keyword, like one of these guys, if it's a unit, test, in, out, link. Um, it's kind of difficult, interesting. Um, but it was fun trying to get this working, I guess you could say. But the token, that was just like the means to an end, just get this working so I could start parsing it into readable stuff. So what this does is it just spits out a string of tokens. So instead of a string of characters, it's a string of tokens that have an identifier with the character. And then my parser is a huge file system. It takes, so sources, I've got 3 C files, each 100 plus lines long, um, kind of parsing into it. And um, so my parser function, you can see there's a warning here. I'm not quite sure what that is. It's right here. I just kind of stopped here because I haven't gotten around to figuring out how I want to do this. But that's for parameters for functions. But I'm just submitting it as it is, and I'm going to continue to work on it. Anyway, so the way this works is it parses the unit. There's different case statements, and then inside it uses my um, parser structs. So any abstract syntax tree is going to have structures to define each of your different types of statements, right? So if it's a if statement, a when statement, a unit, module, or whatever, you're going to need a structure for it. And then the parser is going to read your string of tokens one by one and then parse it. And then if it's not there, it's going to throw an error. It's going to say, oh, this failed for this reason. Something that I do want to improve here is to have a line number be like, oh, I'm going to print out the line number because that's, I feel like, more realistic. If you're compiling it, then it would print out a line number instead of just, oh, you don't have XYZ. But if it was like, oh, expected this after this token with value of this, then it's like, oh, okay, that makes sense. Um, but yeah, that's just something that I want to add. There's a lot of things I want to add. I think I was a little bit too optimistic with this project for how much I could get done in 2 weeks. Uh, but it was super interesting to work on this, to have something come out of it. And I actually there's a lot of different things. So I like parameters, ports, signals, parameters for binds. Uh, I've got abstract syntax. I've got different declarations. I've got um, expressions. Expressions are a whole nother beast. Like I haven't even gotten to logical expressions, right? I can do bitwise expressions, but I can't do logical, just because that's not something I've thought about extensively on how I want to implement that. So that's another like whole thing, um, or like compare statements. So I mean, yeah, there's a whole bunch of things I need to implement to get this to be an actual language that I can do something with. So I'd have to take another probably a week or two just going through it, making the syntax how I wanted it, and making sure it outputs correctly. And it's just not something that I want to cram into the next few days uh, to make it something that I would say is a finished product. So it's something I'm going to revisit probably after this semester and try to finish. Anyway, that is my abstract syntax tree. Thanks for watching.